with Big Imagination. I'm here with Khi, and we're working on our 747 project. One of our big projects, maybe the most important project, is how do we cut this titanium I-beam off and then put it back on. Because the plane with this beam is just too wide. I don't know if you can see how wide this beam goes out like that. Tip to tip on the beam, it's 60 feet wide. We obviously cannot get that down the road. So we have to cut it right here. But when we cut it, then we lose the ability to hook the landing gear back up. So what we've done is we've engineered a series of splice plates that go on top and bottom here, and that will bring the entire wing beam back together again. Problem is, this is titanium, and it's not just ordinary titanium. This is some special concoction that Boeing came up with. And we were having so many problems drilling through the titanium I-beams on these wings that we reached out to CS Unitec, and we got their technical staff to loan us 2 of these amazing MAB 485 mag drills. And Khi here has been drilling away how many holes?
Well over 100 now.
The total is going to be
216, I believe.
216 holes through titanium, and that has been a tremendous challenge until we got our hands on this. So we're going to kind of go through some of the special stuff about this mag drill because we've been super impressed with it. Let's take a look.
So we've got a drill that'll stick sideways onto a steel plate,
Right?
and drill through stuff that you physically could not do by hand.
Right. Titanium is not ferrous, so it's not magnetic. Right, so that's why we constructed this steel plate here. Okay. So the mag drill is hanging onto the steel plate. How does that work? Because I've never used a mag drill before. I've just used a little handheld.
This is an amazing tool. The magnetic base on it is rated for over a ton of magnetic pull against this plate. I could stand on this and this wouldn't come loose from the plate. So it gives a stable platform. You can turn the magnet off, reposition the drill by hand. It's light enough that you can move around and sit it up here. One person can handle this. And then once you're lined up, click the magnet back on and you're right where you need to drill, and it will not move.
Nice.
It's a great tool.
Nice.
It's light enough that I can handle it and position it accurately. You know, it's definitely a two-handed job. It weighs about 29, 30 pounds.
I know for the motor size,
It's a nice...
it's very lightweight for the size of the motor. This is a really big motor in here.
They have a 2-stage magnet on here. While I'm setting it up with this magnet button on, right now they say it's on maybe 50 to 75% of mag base power. So it's easy to turn off and on and reposition. And then once I hit the motor start switch, then it switches the motor on, or the magnet on full power. It's a nice feature.
When we first started the project, we did a test and we got a hand drill. We got a hand drill and tried to drill through this titanium. That didn't go anywhere. And then we had one of our personal home hobby mag drills, and we tried to drill through it, and that didn't work. So CS Unitec loaned us this, but I know the speed, trying to get the speed correct is very important when you're drilling through titanium. Can you tell us a little more about the speed?
This drill has a 2-speed gearbox, so I can switch between high and low up here, mechanical, and it's also got electronic speed control down here on the side, this little red dial. So I can switch between a low range and high range in between gears. So this thing can go from about, I think, 50 RPMs up to about 450 RPMs. I forget the exact number, but for titanium, we're using it in low gear with the speed control turned all the way up so it gets the maximum drill torque.
So there's like those 2 speed ranges, like 50 to 200 or 250,
Yeah.
and then 150 to 400 or something like that. Yeah.
One of the things I've found about this motor is, however they've got the electronics inside, the motor feeds the torque I need and keeps the speed constant. When I am here pulling on this, I am at about 90% of the magnet liftoff pressure when I'm drilling through titanium. It takes a lot of force.
There's an overheating protection called Cool Mag that'll make sure that it doesn't overheat, but we haven't had any problems with
Motor protection. I think when we were drilling on the other side, they got a drill bit stuck and it did a rotor lock on the motor and it turned off, cooled off, turn back on. So it protected the motor. This one also has a neat feature, and you probably can't see it, but there's a little green light down here that shows that the magnet base is getting sufficient steel pull. And if you were to go down on this, beyond what this base will hold, it'll pull that away and it turns the motor off. So it protects you from twisting your bit.
Or this falling off.
Right.
Which would be really bad. We have the safety rope here, but we've never had to use it.
Now the safety, just in case we lose power.
So all the cabling is inside,
Yeah,
right?
the electrical to the motor goes down inside the base here, and it's not out in the way. It's a really nice unit.
Well, I'll tell you what, let's fire it up. Show everybody what it's like to drill through titanium.
Coolant water feeding down through the quill, down through the drill body. This is going through our guide plate and our aluminum. It's been pre-drilled, so this goes pretty fast. And an inch and a half in, then we hit the titanium. There we go. You can see the titanium chip starting to come out now. Yeah, I'm at about 90% of the mag base holding power right now.
Oh, there you go. That's nice.
Okay.
All right, so it's always important to clean up your mess afterwards. So this is the little power cleaner they have. We just come in here, just grab all these chips. That is a lot of titanium. Gabriel's reloading the lube. There we go. We got the Pro Lube here. So we got the CS Unitec Pro Lube. Put that together. That goes up there. That goes through the drill bit. As far as we know, this has only been done one other time, and that was when Boeing cut this off and put it back together again for the space shuttle, the 747 shuttle museum out at the Houston Johnson Space Center. And they gave us advice on how to do this and everything else. But fortunately, they had Boeing come out and do all of this work with all their fancy tools and everything like that. And what we had is we had K-Roo. We have one K-Roo and one CS Unitec, and we did the same thing. So thank you, K-Roo.
Thank you.
Thank you, CS Unitec. And we're gonna get this big sucker down the road. This is all possible because of, well, K-Roo, of course, CS Unitec, and Tom Green, our Green Machine Tool, hooked us up with that amazing drill body. Thank you very much.
Oh, it's great working with you again.
Oh,
We're gonna get this done.
Yes, we are. Take care, everybody. We'll talk to you soon.